All coronaviruses are enveloped viruses, or animal viruses, which consist of strands of RNA surrounded by a membrane. This envelope is characteristic of animal viruses, and analogous to the outer membrane of animal cells. The envelope is encoded with external protein interfaces, surface antigens called spike proteins, or S proteins, for which the coronaviruses are named, resembling a solar corona when viewed in an electron microscope. These interfaces enable viral hijacking of living host cells, as the virus can enter a cell without harming its reproductive capabilities by interacting with an antibody called human angiotensin-converting enzyme. The coronavirus family of viruses have a unique RNA structure which makes them highly adaptive and especially zoonotic, capable of mutating and causing infections across different species of vertebrates including wild animals, pets, livestock, and humans. If the outer envelope of an animal virus is destroyed, the virus is no longer viable, making coronaviruses dependent upon an animal host. This dependency makes the viruses susceptible to chemicals which can damage the viral structure, as well as limits potential spread of the virus to mainly host-to-host contact. However, the virus can survive independently, such as in aerosols or on surfaces, for an indeterminate amount of time, perhaps for several hours in the air to several days in the environment, respectively. There are 4 known types of coronaviruses: alpha, beta, gamma, and delta. Alpha and beta coronaviruses mainly infect mammals, while gamma and delta coronaviruses mainly infect species of birds. A coronavirus which infects people is called a human coronavirus. Pathogenic coronaviruses are relatively common and many are endemic to the global population, responsible for around 15% of the typically mild and seasonal illnesses referred to as common colds. Most coronaviruses do not infect humans, and occur naturally within animal reservoirs, most notably bats. Yet many species of human coronaviruses do exist, and there are 4 main classes of coronaviruses responsible for these common cold illnesses: 229E, NL63, OC43, and HKU1. Occasionally there are discoveries of novel coronaviruses which are more virulent than the common varieties. The coronaviruses which have historically posed more of a threat to humans have usually been identified as beta coronaviruses and followed as zoonoses from a chiropteran reservoir, through a domestic vector, into a human host population. The severe acute respiratory syndrome coronavirus was the first major occurrence of a serious threat to public health by a virus in the 21st century. The virus was quickly contained, and while the disease re-emerged a year later, due to re-exposure between a journalist and a wild animal vector, it was again contained and expelled from the human population. This event brought coronaviruses into the spotlight of focus for the medical and scientific communities, spurring thousands of research papers, and shook the world about the potential ramifications of viral epidemics in the modern era. As a result, we now know much more about coronaviruses today than we otherwise would have.
Researchers believe that SARS coronavirus 2 made an interspecies leap from bats to pangolins, an endangered, armadillo-like animal, considered a delicacy in Asian markets and traded illegally, while those animals were held captive within close proximity. From there, the virus likely made the transmission to humans, where the virus is capable of independently spreading between people and mutating to specifically infect the respiratory tract. This appears to be the case, as there is an 80% match between SARS coronavirus and SARS coronavirus 2, a 90% match between the strain of SARS coronavirus 2 which infects humans, and a similar coronavirus isolated from bats, and a reported 99% match between SARS coronavirus 2 and a coronavirus isolated from a pangolin found in China. On the 11th of March 2020, the World Health Organization declared the incidence of a novel coronavirus a pandemic, meaning a multinational outbreak of cases has occurred, measured by a spike in observed cases over a relatively short period of time. Pandemics are typically caused by an emergent or newly discovered infectious disease, owing to a new development of pathogenesis. The current containment efforts against SARS coronavirus 2 in 2020 comes as the 3rd major outbreak of a coronavirus resulting in a pandemic in recent memory, following severe acute respiratory syndrome-linked coronavirus in 2003, and Middle East respiratory syndrome-associated coronavirus in 2012. There was also a swine acute diarrhea syndrome-related coronavirus outbreak among livestock in 2018.
Because coronaviruses are dependent on animal hosts and can sometimes mutate to become species-specific, it is possible to contain the number of cases in the human population to a degree. The virus cannot survive ex vivo for extended periods, and if prevented the opportunity to spread, the virus may level out as each infected individual fights off the virus.
Because the 2019 novel coronavirus is an emergent species of virus, likely a recombinant of two previous coronaviruses, there is a limited immunity to the virus in the global human population. This means that, as of early 2020, defenses such as herd immunity, vaccinations, and the individual adaptive immune system are not available to counteract the epidemic. Given the rapid spread of severe acute respiratory syndrome coronavirus 2, and its novel discovery, there are still many unknowns about how to combat the virus and to treat the disease. Unfortunately, the current incidence of cases for SARS coronavirus 2 seems to be taking an exponential curve, at least in the United States where the majority of cases have been identified. As an emergent pathogen, the general population lacks specific immunity against the virus. As a particularly contagious animal virus, the disease is capable of spreading in an asymptomatic, or incubation phase, between people who do not show signs of infection. Infection statistics are in the tens and hundreds of thousands and rising. However, their statistics can be somewhat deceptive. Due to the unique challenges of this virus, every single case poses a threat to absolute containment, representing the potential for exponential growth due to lack of population immunity, healthcare shortages, and the ease of respiratory spread among healthy people. Because it is not likely to have an adaptive immune response against any new disease, until learned immunity and memory cells can be acquired. People will mainly have to rely upon their innate immune response to survive potential infections of SARS coronavirus 2. This immediately puts all patients of COVID-19 more at risk, particularly the aging population, as the innate immune response can be slow to respond in some cases, and can inadvertently cause damage to healthy tissue while pursuing the virus through the uses of acute inflammation and cytokine storms. The overwhelming majority of cases will be mild. People in the age range of 60 years and older have the highest rate of critical cases, including respiratory tract infections or pneumonia. However, the virus has been known to cause serious illnesses in people of all age ranges, both in those experiencing underlying health complications and who are completely healthy. Relatively few infectious agents have the ability to cause serious infections in otherwise healthy adults and adolescents, raising the level of concern over COVID-19. Even in the majority of mild and asymptomatic cases, if the virus is allowed to spread freely, it would be near impossible to accurately measure or contain such a highly contagious agent. Once the virus attacks an infected person, while the case may appear mild at first, it can also weaken the immune system, making the patient susceptible to opportunistic pathogens which might not otherwise cause a threat. It is important to remember that the health burden from other maladies such as influenza will not go away just because a new infectious disease has appeared. People are still being infected by common viruses and bacteria and will continue to present at hospitals and health facilities for the numerous reasons people regularly require medical assistance and social care. A new and highly contagious epidemic of the 2019 coronavirus has the potential to overwhelm an already dubious healthcare system. Tens of millions of Americans have no health insurance, and millions more are underinsured and lack job security if fallen ill. The health burden of SARS coronavirus 2 is already cause for concern. However, there is also an economic component to consider as businesses close, employees are made redundant, and purchase patterns change. The global market drop starting off 2020 was one of the largest in history, with no clear path set for how to adjust to these massive and impromptu systemic changes. Fortunately, immunological studies on other antigens and coronaviruses suggests that the COVID-19 virus will eventually largely subside and could be susceptible to effective antiviral measures, including containing transmission, blocking the virus's capacity to invade the epithelium of the respiratory system, and bolstering and more effectively managing the body's immune response to the disease. The best solution to any pathogen is to stay safe, stay smart, stay sanitary, and stay informed.